so a question came up about the quizzes, on the quiz, about the last 3 problems on the quiz. So here is a little rundown of that. So it tells you that it's a normal curve. So a normal curve is one of those things that you just memorize the numbers. And so a normal curve looks like this. In this part right here, oh goodness, let's see if we can draw it a little straighter. In this part right here, you have the mean. And then you're going to go out 1 standard deviation, 2 standard deviations, 3 standard deviations, and you're going to find those values. 1 standard deviation, 2 standard deviations, 3 standard deviations, and you're going to find those values. Now, here's the part to memorize. In between 1 standard deviation on either side, that's where 68% of the data is located. Okay, so 68% of the data in any normal curve distribution, whether it's a person running, whether it is 3rd grade impact scores, whether it is, body mass index at a gym, if it is on a normal curve, 68% of the data fall within 1 standard deviation, within that red region. Okay, so the blue region is 2 standard deviations, and that percentage that falls in between those two would be 95%. And the green region is going to be 3 standard deviations, and the number that falls between the 3 standard deviation mark is 99.7%. And that's how all normal curves are created, regardless of the situation in which they're found. Now, we're going to look at our normal curve. Our normal curve that you see up here, let's use orange, it has a mean of 15.2. Okay, so to get to this red line right here, you're going to take that mean and you're going to add 1 standard deviation. So when you add that up, you get 16.1. So that would be the value for that red line there. Now, what you're going to do to keep going out is you're just going to add a standard deviation every time. And in this problem, the standard deviation is given to you. That's where I'm getting the 0.9. So 16.1 plus 0.9 would be 17 right here. And 17.9 would go right here. So each time, you start at 15.2, and each time you add 0.9 to it. Okay, if you're going in the other direction, you're going to subtract it. So this would be 15.2 minus 0.9. And I did that, put that decimal in the wrong place. Let's fix that. Which would be 14.3. Okay, and so backtracking from that, 14.3 minus 0.9 would be 13.4 here, and then 12.5 here. So you just take 15.2 and you subtract 0.9, subtract 0.9, subtract 0.9, and that's how you're getting those values. Now that is the design that you're going to have to answer questions 7 and 8 and 9. So the question said, what is the percentage of times that are more than 15.2? Okay? So here's 15.2. And here's more than that. Well, that's actually a fact that's not on the normal curve. So what you have to remember is that the mean divides it in half. So half of the data is above the mean and half of the data is below the mean. So if I ask you how much is above 15.2, that would be half of it. So you would pick 50%. Okay, and that's how that one would look. And then we're going to refer back to this every time. Okay, so the second one said how much was less than 17 seconds. Less than 17 seconds. It's the same dynamic, less than 17. Okay, here's 17 right here. Okay, getting from here to here is 50. And getting from here to here is another mark. Okay, so let's figure out what it would be. There's lots of different ways to figure it out. Here's how I usually do it. I know that if 68 is in the red region, then that means that would make up 34% here and 34% here if I was doing the 68%. Okay, so 95%, if you were counting that one, dividing that one in half, in this blue region over here, you would have 47.5. In this blue region right here, you would have 47.5. Now there's other ways to do it too, but that's the part that's easiest for me. So if I'm looking for how much is less than 17, I'm going to take this pink part and get all the way to the halfway point. So I'll have 50% to the halfway point right here. And then I'd have this much to go from here to here. So I would have 97.5. That's between here and here. Between here and here. 97.5. Okay, so then you had a third one. How much is between 15.2 and 16.1? Here we go. Here is, let's use light green. Here's 15.2, and here's 16.1. The part that lies in this region right here would be 34%, because it's half of 68. So it would be 34%. Okay, so just trying to backtrack this one more time, what you would have to do in a problem like this is you're going to start out and you'll draw your curve. You're going to put your mean right here. You're going to put your mean right there. Go out 1 standard deviation, 2 standard deviations, 3. 1 standard deviation, 2 standard deviations, 3. And then you know, then in this region right here, you're going to have 68%. If you wanted to break it down further than that, half of 68 would be 34 and 34. And that's how that piece would look. Your next part, we'll do orange. Between the orange, that's 2 standard deviations, you're going to have 95%. Now if you broke that in half, you would have 47.5 on this side and 47.5 on this side. That's the orange region. And then lastly, you'd have the green region, which is 3 standard deviations. And this whole thing from here to here is 99.7. That's what it would look like. So if I asked you anywhere between, say, this region right here, well, that's half of 68, so that would be 34. If I asked you how much was between less than here, we'll say, how much is less than this one? Then if you figure that out, you could just look at it from that part. We would have 50. This whole thing from here to here is 50. And it's 50 except for this little piece. So 50 minus 34 would be 16. And so this would be 16% because that's what's left over. And so I could ask you a whole host of questions about the normal curve. Let me take some of this markings off. But this is basically how every normal curve is designed, regardless of the situation in which it came from. So if your question was, I don't know where to get the percents are a given. Those 3% are the parts of the normal curve. They're given.